This is a short demonstration of the standing model. So this is as you can see here, I have opened a model, the standing model main file in the AnyBody modeling system, and we have only the most important AnyScript code defines in this model. So first of all, I'm going to load the model by clicking on this button here. And we see that it's loaded. Now you see on the left side here, run application, and also some other options here. So let's have a look at the code in here. So first of all, we have here a file called mannequin that describes the posture and the motion of the subject in there. Then we have a file here, humanModel.any. So in here we include the human model. We have in the model section an environment file. So this is where we define the environment. So what is happening around or what is happening to the human model. And then we have here joints and drivers. So this is how the motion is applied to the human model. And then here we have a study. So we have gravity defined in, so that's X direction, Y direction, and Z direction. So we have gravity in minus Y direction. We have N step of 1 and T end 1. So it's a 1 second simulation, and we only analyze one step. So I'm loading first. I'm opening the model view. So we see in here the subject first in the air. So I can change now some parameters so we see what is happening. So first of all, environment is empty, so we have only a global reference frame in there. That would be that file here. We see again X is going to the front, Z is going to the side, and Y is upwards. So gravity is in minus Y direction. If we open the mannequin file now here, so we have three subfiles in here. One is called pose for position, one is vel for velocity, and loads. So in here, when I open that, so we have a folder called posture. So this defines the start posture of the subject. So first of all, we have the position of the pelvis. So it is it's 1.16 meter in Y direction and 0.046 centimeters in X direction. So we could change that. Here this is pelvis rotation, pelvis thorax, angles and extension, lateral bending rotation. Then we have for the right side, here this is for the arms, glenohumerus, shoulder, elbow, wrist, for the individual fingers, motion. Further down here we have a hip flexion, abduction. So abduction would be 5 degrees, knee flexion, so there's no flexion in here, and for the ankle and for the left side we are just mirroring everything, so we are referring to the value up here. When I open now the second file, velocity, so it's basically the same again, but this is then the speed, either degree per second or meter per second, what is happening in here. So for example, if I type in here now for a hip flexion 5, so it would be 5 degrees hip flexion per second. And the last file in here is loads, so we can apply loads in this X, Y, Z direction to shoulder, elbow, hand, hip, knee, or ankle. So for example, if I have now in minus Y direction 100 Newton or 1000 Newton, so I would have in the right hand here a force of 1000 Newtons applied. So first of all, I'm going to run the model without any changes. So I just click on run application. So the model will go now to its start position. We see there's some calibration of the muscles going on now already. So it's trying to do inverse dynamics. Here we see the progress. So it's working on step 1 and we are finished already. So it's standing here. Because I don't have any loads applied or anything, everything is quite standard and basic. So I can open here again on the window. You will find the chart view and have a look in here under study output model, human model. I find a folder called selected output. So in here I can, for example, look at joint direction forces in the trunk. So I could look here, for example, what is the proximo-distal force between the lumbar vertebra 3 and 4, so L3, L4 proximo-distal force. Because it's only one step, it's a straight line, but you can see it's almost 400, so that's 400 newtons force in proximo-distal direction in between L3 and L4. Can close it, and we could also look at the right side. So we look at the right leg and we could see joint direction forces in the hip, again proximo-distal. So we have around 350 Newton in the hip, and for example in the knee we would have the, so in here it's minus because the reference system in the knee is different, but we would have 100, 160, oh no, that's anterior posterior, so that's from the front back, so that's in X direction, so we would have minus 16. And look again at proximo-distal, we would have 480 newtons in that reference frame, so in the knee. So now let's change a little bit. So as I said, I could apply a force to the hand, so let's apply 1000 Newton, so this is a lot, so I can load the model again by pressing F7, and I can run the model again just by clicking on or pressing on F5 on my keyboard. And it will do the calibration again and run the inverse dynamics. And we have applied now a force of 1000 Newton, that's quite a lot, to the right hand. So basically we have 100 kilos applied here. So you see the color of the muscle changes, so and we also get a warning in here, so we have an overload muscle configuration. So if you look now at the graph, there we go, it's here. So we see we have huge forces in the knee, so everything is overloaded. We can look again at the arm, for example. So if you look at the reaction forces in the glenohumeral joint, would be here. So we have 1700 newtons in the shoulder and the anterior posterior, and even more in the distraction force. So clearly that was too much, so we're going to change the force again. So we'll remove the force in here. So in here you can of course apply different load scenarios. So what else what we could do is now we're going to do a motion. So instead of only one step, we're going to record 3 seconds. We're going to divide it into 10 steps. And we're going to open the mannequin file again. So we leave the initial posture the same, the position, but we're going to introduce a motion. So we're going to introduce glenohumeral flexion of -5 degrees per second and an elbow flexion of 10 degrees per second. So that means we should get a change of -15 because we have 3 seconds, and here 30 degrees in the elbow. Because we have here t end of 3 seconds. So I can load it again. Now I can run the model again. So we are back in the initial position. Have some calibration run, and now we see here we have we are working on step 0 of 9 already. Step 1. So if I open the chart here again, so let's see something is moving in here. So we have changing forces. Can also display the numbers itself here. You can look at the glenohumeral anterior-posterior force, for example. So this is in the right shoulder. And let's we see also clearly how the elbow is changing. So the shoulder motion and those 15 degrees are not visible very much. So yeah, he's going to the back. You see that as well. So this is, I can try and replay that, which is here under study, replay. So let's do a replay. Then you see this motion here. So it was not a very large motion, very short motion, but you can see in here then, and also for the muscles, how those muscles work, what's going on. So on the selected output you will find the some selected values, and then if you go, for example, on the right leg, you find for all the muscles that are in the system. So there's several muscles defined. Gluteus minimus is divided into several fascicles and medius and maximus, and or those leg muscles, quadratus femoris. You can look, for example, in there and see what force is happening in there, what activity does it have. So if you want to know all the detailed information. So this is a very short, basic overview of the standing model.